This is a video from the Exam 3 review. Part A, find the intervals on which the function is increasing and decreasing. Part B, identify any local maximum or local minimum. Part C, what, if any, of the extreme values are absolute? So find the absolute max and min. Let's take a look at this example. Suppose we have g of t equals negative t squared minus 3t plus 3. The domain of this function is negative infinity to infinity. We're going to take the derivative. G prime of t is negative 2t minus 3. Set g prime of t equal to 0 to find critical numbers. And when we do, we get t equals negative 3 halves. And so we're going to apply the first derivative test. And so we set up an interval. We're going to test a value inside each of those intervals and use that to determine whether the function is increasing or decreasing on that interval. And so we have the interval negative infinity to negative 3 halves and negative 3 halves to infinity. And so I'm going to test t equal to negative 2 and t equals 0. It turns out that g prime of negative 2 is greater than 0, so g is increasing on the interval negative infinity to negative 3 halves. And then g prime of 0 is less than 0, and so the function g is decreasing on the interval negative 3 halves to infinity. And remember, when you go from increasing to decreasing, we have a max. And so therefore, g has a local maximum at g of negative 3 halves, which is equal to 21 over 4. And again, I want to stress, g is increasing on infinity to negative 3 halves. G is decreasing on negative 3 halves to infinity. And g, again, has a local maximum at g of negative 3 halves, which is 21 over 4. And it turns out g has an absolute max at g of negative 3 halves, which is 21 over 4. And so we have no local minimum and no absolute minimum. Example 2. Suppose f of x equals x times natural log of x. The domain here is 0 to infinity. Take the derivative. F prime of x is equal to 1 plus natural log of x. Set f prime of x equal to 0. And so that says 1 plus natural log of x is 0. And I want to isolate natural log of x by subtracting 1 on both sides. And so natural log of x is equal to negative 1. And so x equals e to the negative 1. Because remember, you can think of this as log base e of x equals negative 1. And we translate this into an exponential equation. And so e to the negative 1 is x. And that's what this is. We set up our intervals. We have 0 to e to the negative 1 and e to the negative 1 to infinity. I'm going to test x equal e to the negative 2 in the first interval. F prime of e to the negative 2 is less than 0, so f is decreasing on the interval 0 to e to the negative 1. Testing x equal 1, we see that f prime of 1 is greater than 0, and so f is increasing on the interval e to the negative 1 to infinity. And remember, when you go from decreasing to increasing, we can say that f has a local minimum at f of e to the negative 1, which is equal to negative e to the negative 1. And then furthermore, f has an absolute minimum at f of e to the negative 1, which is negative e to the negative 1. And that'll do it for this video. And I did 2 examples on determining which intervals are increasing and decreasing for a given function. And I will make another video where you have to determine concavity and inflection points. We need to be able to do that as well. And then I'll make another video where you have to sketch graphs. Okay, thank you.